So now this is the mu j. So let's say this is the mu j1. This is the vector which gives rise to mu j1, and this is another vector which we call it as a mu j2, and this is the resultant vector which we call it as a mu j. So now this mu j is the vector quantity which can be written as a magnitude and direction. This is the magnitude of this vector and this is the direction. This is the angle between j1 and j. Similarly, this mu j2 is the magnitude of the vector and the direction. Direction is the angle between j2 and j. So now we have to solve this equation now. So here we have j is equal to j1 plus j2. First, we have to find out the angle between j1 and j. Angle between j1 and j. So this equation can be simplified as j minus j1 is equal to j2. Squaring both sides. So as a resultant, j2 square is equal to j square plus j1 square minus 2j into j1. So as a resultant, into cos of angle between j1 and j. So now from this equation you will get the cos of angle between j1 and j is equal to, this goes in this side, this goes into this side, so j square plus j1 square minus j2 square divided by 2j into j1. This what we have. This is from this equation by using the cross multiplication. So this goes to this side, becomes positive, और ये इस तरफ आ जाएगा तो negative हो जाएगा, और cross multiplication gives this term. Similarly, from this equation, so this is the angle between j1 and j. We put it this angle over here. Similarly, we have to find out the angle between j2 and j. So here, from the same equation here, we have to find out the angle between j2 and j. So this can be placed over here. So therefore, from this equation, j2 is equal to j minus j. This is the j2, so this is j2, this is j2, this is j2. So here we have a j1 which is equal to j minus j2. So again, from this equation we can easily find out the angle between j1 and j2. So here j2 is equal to j minus j1. From this equation, you will get the value of angle between j1, j2 and j. From this equation, you will get the value of angle between j1 and j. So this gives you, squaring both sides and using cross product, you will get a cos of angle between j and j2 is equal to some value. Similarly, here cos of angle between j1 and j gives you a certain value which is equal to j into j1. And these equations of cos values will be substituted over there, then you will get a value of mu j. So from this mu j, you can easily find out the G factor. So you have to process further. This is assignment. This is the simple calculation you can perform easily. So we are stopping here. Okay, what is the G factor using LS coupling or JJ coupling? So there is a simple calculation you can do yourself. So now what we are discussing, okay, what are the X-rays and how they are produced. X-rays क्या होते हैं और वो किस तरह प्रोड्यूस हो रहे हैं, तो वो हमें डिस्कस करना है. Simply X-rays. What is the X-rays? So X-rays is simply, we call it as a high energy electromagnetic wave. X-rays, we call it as a high energy electromagnetic waves. So here the X-ray can be classified in two terms. Number one, which we call it as a continuous X-rays, or we call it as a Bremsstrahlung radiations. This Bremsstrahlung radiation is sometimes called braking radiations. और जो दूसरा है, this second term is the characteristic X-rays. So now, what is the continuous X-rays or Bremsstrahlung radiation, and what are the characteristic X-rays? We have to discuss it one by one. So let's say we call this is number 1 and this is number 2. So first we are discussing number 1. Let's say this is the atom and these are the orbitals. The electrons are in these orbitals, are in this K shell, L shell. This is the K shell, L shell, M shell, N shell, and etc. So the filling up of the electron in each shell follow the formula of 2n square. N is the principal quantum number. It means in the first K orbital, K shell, there will be 2 electrons. In the L shell, there will be 8 electrons, and etc. So now what is happening? When the electron, outside electron, this is the electron. This electron is the free electron. When this free electron, high energy electron, this is the high energy electron. High energy electron. How much high? Its energy is approximately equal to kilo electron volts. इसकी जो energy होगी वो approximately in the range of kilo electron volts. So it means this is the electron which are coming out from the high voltage accelerating source, So as a resultant, when this electron passes near the vicinity of an atom, this is the atom, this is the atom. So when this electron passes near the vicinity of atom, as a resultant of the Coulomb interaction between the nucleus and the electron, this electron changes its path. This electron changes its path and its energy is decreased according to the law of conservation of energy. This decrease in energy is converted into the electromagnetic radiation. And these electromagnetic radiation is the high energy radiation, which we call it as a continuous or brainstorming radiations. So as a resultant, if we say that its energy, kinetic energy is K1, yeah, Ki, and the final energy is Kf. So as a resultant, this emit out the energy in terms of the electromagnetic radiation, which is equal to h nu. This h nu is the energy of this radiation is coming out by the deceleration of this electron. According to the law of conservation of energy, it neither be created nor be destroyed. So this energy is converted into the electromagnetic radiation. So this total energy, EI, which is the initial energy, or we call it as the Ki, is the initial kinetic energy of the electron, is converted into the energy of the photon, plus it possesses a certain final energy, Kf. So this h nu is equal to Kf minus Ki. Yeah, h nu is equal to Ki minus Kf. K indicates the kinetic energy. So this is the energy of the radiation. Why we call it as a continuous? Because from the source we have so many electrons is coming out from the cathode, from the source. So one of the electron is emitting out the radiation. There may be the other electron which also coming close to it, again emitting the radiation. There may be the third electron which is coming close to it, again emitting the radiation. So this radiations possesses all possible wavelengths, possesses all possible energies. This depending upon the impact parameter of the electron with the nucleus. It means if we say that this electron is passing near the vicinity of the nucleus, so it radiates more energy. The change in energy, kinetic energy of the electron is less, so it radiates more energy. If the impact is increasing, impact parameter means the distance from the nucleus increases. So as a resultant, the Coulomb force decreases. So the Coulomb force decreases means the energy decreases. This is h nu 1, which has a higher energy. So this is h nu 1,